All right. Hello, everyone. How you doing tonight?
Ready to
All
learn. Same here.
right. So, where are we going to start tonight? So, we have this review that's in the Canvas announcements so that we all have the same numbers. Because if we do it from your own computers, you're all going to have different numbers. So that's why I do this handout of it. So that as we're working through problems, we all have the exact same numbers, the exact same wording, the same names, and all that kind of stuff. So you guys dictate this. So tell me a problem number, and that's where we'll start.
Hi,
Uh,
Professor. Would you be able to go over question number 3?
yes. Okay. Look at it in camera view there. All right. Oh, geez, I need something to write with. Okay. So I kind of worked this one out already, just the frequencies, so that we don't need to waste time counting there. There are two here. And when we're saying two here, that means it's 0 through 5, or not even 5, it's 0 through like 4.99. Then this next one is 5 through 9.99 because the equal to sign is not underneath that less than sign. So this one is saying it's less than, or this one reading it the other way, x is greater than or equal to 5. So the 5 is included in this one, but not in that one because there's no line underneath it. Does that make sense, I hope? I think
Yes.
that's something that some people get kind of messed up on this problem. All right, then there's a 3, a 4, a 7, and an 8. And altogether, there are 24 of them. Okay, so the best way to do relative frequency, and relative frequency is different than just frequency. Frequency is just how many times it occurs. So how many times does it show up? That's frequency. But relative frequency is how many times it shows up over how many total things are in our sample space. And if we counted up all these numbers, there are 24 of them. You could change this into a decimal, but I suggest just leave it as a fraction, unsimplified. You're going to get the answer correct as long as you type in the right numbers. So we've got 2 out of 24, 3 out of 24, and so on. Okay, so the bin width. So here we're starting at 20. Then we're going to 21, 22, 23, and 24. Remember, we're not going to 25 because that line's not underneath. So our bin width is 5. And then construct the histogram. So this one, we kind of need to mess around with these numbers here. So we're going to use these, well, 0, 5, 10, 15, 20, 25. We're going to use those as our bins because that's what we created here. We know how many are in each of those different areas. So this is 5, and I know you guys can take the dots and move them around. So move those dots around. Do 10, 15, 20, and 25. So 5 goes up to 2. And I know these aren't all the same size here, sorry. This is just kind of a rough thing. 3, 4. I think you guys get the idea of this. Then I would just keep going and do the 7 and the 8. So 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25. Okay. So that's constructing the histogram. What proportion of teenagers played at least 15 hours? At least 15 hours. So at least 15. We want more than 15. And this is telling us that the 15 is included here. So at least 15 would be the 15 through the 25, or the 7 plus 8, which is 15. I think I just wrote down a number wrong someplace there. So 7 plus 8, 15 out of 24. What percentage of teenagers play less than 15 hours of video games on weekends? So less than 15. So now we're looking at these 3 areas. So 7, 9 out of 24. All right, so when I was going through and looking through some of the answers that people were typing in, I noticed that sometimes people wrote the fractions and sometimes people wrote the decimals. I'm going to highly suggest that you write the fractions. When I've seen people do the decimals, I've seen lots of rounding to the wrong place value. And that's been getting people some wrong answers. If I divide this out, 9 divided by 24. If you write the whole decimal, you'll for sure get the right answer. But if it's a really long decimal, you don't want to write that whole thing out. You should be able to just write it as a fraction. If you can't write it as a fraction, if that fraction thing isn't there, write out the whole decimal, or at least go 4 places after your decimal point. If you go 4 places after the decimal, you'll be safe, but as long as you round. So if this number is 5 or higher, the next one, make sure that you round. That's where I've been seeing little errors. There's somebody just writing like 0.4 or 0.37. So you got to watch those little things. You don't want to lose points for those little things.
Okay, thank you for going over that. I think I was getting my denominator as 25 for the 25 data points that I was counting. I think that's what messed me up.
Oh, did you get 25?
I counted 25.
7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24.
Okay, I think my problem on Edfinity, I'll send you a screenshot of. There's 25, but yeah, that was one that I got wrong. So thank you.
Oh, okay. Okay. All right. Good start. What are we going to do next?
And because that one is asking for what percentage of teenagers, we would round it off to 38%, right?
No. If you do it as a percent, do it as 37.5%.
Oh, perfect. Thank you.
Uh-huh. Good question. If it was a longer decimal, if it was like 0.3755421, then yes, round it to 2 numbers after the decimal. So this would be 37.5421. rounded to 37.54. Those are little things that I saw people getting points marked off for, so be careful about that, because it seems to be the way Edfinity grades them. All
Yeah,
right.
thank you. That's a good one. Thank you, Professor.
Uh-huh. What question are we going to do next, or any other follow-up questions on this?
Can I do 5? I mean, can you do 5 for me, please?
Okay. Number 5. Okay. So, sorry, I got to keep my papers in order. Otherwise, I'm going to go crazy in a little bit. All right. So again, I counted these up. I got 8, 10. I don't know if we can hear my dog barking now. Sorry. So there's 25 numbers there. So this is 8 out of 25, or 0.32% or 0.32.
Oh, so how did you choose the frequency? The 200, between the 200 and 300?
So this one goes from 200 through 299.99. Because the
Okay.
line is underneath the 200, so we include the 200. The line is not underneath there by the 300, so we don't include the 300 there. We include the 300 down below.
Okay. So if the line is there, you don't include the 300.
Right. When the line is there, you include it. When it's not there, you don't include it. Wherever the line is, include that one. But like I was saying, it counts these fractions as correct. So if you can just type in the fractions, type those in.
I was finding that I wasn't even putting them in as decimals, so I was glad to hear that was because I just feel like that's easier. That makes a lot of sense to me. I struggle once it becomes a decimal.
Yeah.
Yeah, I was also doing that on the homework. So on the exam, it is acceptable to put in a fraction versus the decimal.
Sorry, taking a drink of soda there. Yeah, because it reads it the same way.
Okay, perfect. Thank you.
So,
All right, then we're going to do the same thing down here. We're going to make the graph. We're starting at 200. So our first spot has to be 200. And we're going by hundreds. So 200, 300, and so on. You can see I just kind of grabbed these. Oh, this one actually is from this problem. It said prices. I just grabbed lots of graphs from different places. And then we do our bars. I'm not good at drawing these. Let's see. So now we go up to 10. That's a real, oh, sorry. I went to the wrong spot.
So when you're doing them on the practice simulating thing, sometimes I can't get the bars to be, I think they're right, but when I put it on here on the bars, it's not right. So am I supposed to go from right to left?
You should always go from left to right, I would think.
Okay.
Left to right.
I do
I'm
be
just
going
kind
left to right. I think I do go left to right. I just can't get them quite right.
Anyone have any ideas or suggestions on that? What you've tried?
I just try resetting it with the little button. It says reset the graph, and sometimes it takes like 2 or 3 times.
Okay. So
Yeah,
you've experienced
I've
problems too.
Yeah, I've reset the graph before too, and then what I found out why I was getting dot points was I wasn't moving the bottom dot on the actual x-axis. I was only moving the dot that corresponded to the y-axis in hopes that it would move the x. You have to move
Mhm.
both.
So yeah, so I probably move these down here first.
Mm-hmm.
Get these in the right spot first. So then you can do the height ones.
Yeah, I do it that way. I move the
I was
bins
moving
on
the
the
bottom.
bottom
Right. It's like
first
the
in the
what is it, like
intervals that they need to
crawl
be.
before you can walk. You do like the little ones and then pull them up higher.
Mhm.
It makes sense though. Thank you, Professor.
Mhm.
Thank you.
Okay, what question is next?
Number 26, please.
Oh, I just was thinking we were done already. Okay. All right, I was wondering when we were going to jump into this. Oh, wait, no, 26. Oh my goodness. Where's 20? Yes, it is one of these. Okay. All right, so this one can't exactly show you the whole thing on the screen because I don't have that applet up. But since this is asking for the less than or equal to, we're going to use this button. So use that button for less than. And then down below, this is where I think people get the wrong spot here. So it gives you P of X less than or equal to, and then there's nothing there. And then we want to get as close to 0.41 as we can. So we're going to type in 2.35. And when we do that, we should get 0.3409. So when it's giving us the Z, we're plugging the number into that blank spot.
I'm sorry, maybe it's just because it's late and my brain is trying to comprehend this, but where are you pulling the 2.35? Are you getting that from the table?
No, it's
Okay.
if we had because this thing would come up.
Right, in the little
Yeah,
picture graph.
right. So, and that picture is P parenthesis X, and then the less than or equal to, we would type in 2.35 after that.
Okay. And will there be questions where that little where the applet is embedded in the question or no?
There could be.
Okay. Okay, good to know. Those
Okay.
didn't trip me up as much when I was doing them when I had like the full visual because it was making sense when you plug it in, like I don't know, sort of what would come out on the other side, but some
Mhm.
seeing it on its own, I have a hard time computing like what it's asking for.
Yeah.
Yeah.
But like naked problems with no context.
Right.
Mm-hmm. All right.
Hi, Professor. Sorry interrupting. I know you may have just said it, but I don't think I followed on how you got 2.35.
Um, so when you're in the problem, that applet comes up that's got px less than or equal to. And then there's a space here. In that space, you're going to type in
Wait, are you putting in the one for 27? That's what it is, I think.
That's what it is. I'm doing
Okay.
7.
Okay.
Yes. Look at
Okay.
that.
No, that makes so much more sense
Oh,
now.
it totally does.
Okay.
Okay, got it.
You, Erica. I'm actually I'm glad you asked again because I would have looked back at this and been like, wait, what?
How did that happen?
Yeah.
Numbers come from- Yeah. All right. Does that look better now?
Yeah, absolutely.
go.
We just
Okay.
we plug that number in
Yes, the
and it's
2.35. I even wrote 2.35.
yeah. That's funny.
Okay.
Thank you. That makes sense.
Mhm. Oh, you know what though?
Oh, so that was not right.
No, this is, sorry. If you do this in the applet, I wrote the wrong thing here, but this is the right thing for negative 0.41.
Oh, okay. Okay, I see.
But the
And then-
2.35 shouldn't have been there.
And this one is the 2.35. And this one gives us 0.9906. I just wrote the wrong number on my answer key that I use with my in-person class, and no one pointed that out to me. Yikes. Hope that didn't confuse them.
Just a follow-up question. So the 0.3409, that's from the Z-score table?
It's not from the Z table, it's from using that applet. This
Okay.
one has the applet in it. That's why these things are here. If we did it in the Z table, negative 0.41, negative 0.41. I don't know if you can read that. That's very tiny there. 0.3446. And this is where this is driving me crazy that wait, oh no, 0.041. I did maybe it's a little bit closer. 0.3409. 3.041.3. Oh, it is exactly the same on this one. That's good. 0.3409 and 0.3409. But this one has the applet where this is there. And it says equals, or find P of Z less than or equal to it, and you type in that negative 0.41, and that comes out.
Yeah, I remember when I did the learning assignment for this one, we just need to make sure we enter the correct number and it will pull up the Z table number. And then I didn't even have to look at the graph. I would just look at the number and then plug it in the box. Does that
Right.
make sense? Yeah.
Yeah.
I think what was what's confusing is the brackets. So if it's less than or greater than, and there was some problems where we had to calculate in between
Yes.
too.
Yeah.
Professor, could we please just go over number 29 just in case?
Yeah, I was gonna do that one actually. Okay. So this one, if we're using the app, if this is one that has, this is actually one that would have this on it because it's got these choices here. As opposed to this one. See, these are both asking about lies to the right. This one flat out says lies to the right. This one just says Z is greater than or equal to, as opposed to these that said Z is less than or equal to. Okay, less than and then greater than. Okay. So less than or equal to, and then it has that bracket there. On this one, we don't want the less than or equal to, we want the greater than. So greater than is farther to the right, use that one. Less than, farther to the left. Greater than, use the one to the right. And you just type in that 0.26. And you'll get 0.3974.
Sorry, Professor, even though it's saying Z is greater than 0.26, but then you're writing Z is less than 0.26, is that right?
But we're using this symbol.
Okay,
So this symbol is telling us it's going to give us greater than.
okay,
So this one's saying, I'm going to give you numbers this way.
right,
And this one says, I'm going to give you numbers that way.
okay.
All right, so now we didn't do any on the table, so let's just do this one on, oh, this is Z equals. When we have the applet, this one is really easy, but when we don't have the applet on this kind, determine the area under the curve that lies to the right of Z equals 0.38. So the table gives us data to the left. That's what the little graph on the top is trying to show you. And you will have access to this. It's going to pull up just like it did in the homework. Because you can't have a printed version of it because you could have notes on it, and ASU frowns upon that. But you'll be able to pull it up on the screen. It's in the problems, and then if you ever lose it, it's in the instructions on the left side of the screen when you're taking a test. Click on instructions, and this will pop up, or you'll see that you can get to this and the Desmos calculator from there. All right, sorry. So this, if Z equals 2.4, I'm going to look up 2.4. So here's 2.40, and I get 0.9936. This one's nice and easy. Did I look that up right? Oh, no, it is not 2.4.
0.38.
0.9918. Okay, so I just looked up 2.4 and I have to match that up with the 0. So 0.9918. Now, if I want to the right down here of Z greater than or equal to 0.26. So I'm going to look up 0.26. 0.26, and that's 0.6026. 0.6026. Looked up the right number. Where did I get the number I was looking up from? I'm making up problems. Let's do Z equals 0.38. Oh my goodness. 0.38. We'll stick to the problems on the page. That'll be easier. 0.38 is 0.6480. .6480. So the table, remember, gives us data to the left. So when it asks for the left, we can just leave it as is. But when it asks for the right, you guys tell me, what do we have to do with this number?
We subtract from 1, right?
Exactly. So 1 minus 0.6480. And I'm using my calculator that you guys can't use on your test. Sorry. I just don't want to bring up the Desmos calculator. So 0.352. When I subtracted that 1 minus the 0.64.
And that's to the right. Whenever it adds to the right, you subtract by 1.
Right.
Okay, could I ask if we could jump to number 23? I get real confused with the standard deviations.
Oh. I'm sorry, you said 23?
Yes, ma'am, 23.
Okay.
I had to double check too. I got my pages all over the place.
Okay. Have you not been using the Desmos calculator?
So I have, and for lack of going into a whole explanation, I thought I had it figured out where I could input the table and then sort of figure it out from there. And I feel like figuring out the what lies within one standard deviation, two, and so on, I can get those. But something about going from the mean and then just getting the standard deviation, I get stuck.
Okay. How are you at finding the mean?
I'm okay.
Okay.
Okay, great.
Okay. So on this one, a common mistake on this one is, well, no. Yeah, the common mistake on this one is for finding the mean, we've got a score of 10 and 6 students had that. To get the class average here, so we'd have 10 times 6 plus 9 times 13. Because, oh my goodness, my dog's licking my feet. That kind of startled me. There are 13 people who scored a 9, so we need to account for all of those. Then there are 12 people who scored an 8. Plus the 7 people who scored 11. Plus 6 by 13. And then plus 5 times 5. And we divide all of that. So if you put a big bracket around here and here, so you have an extra bracket at the very beginning when you start, and then do all your little brackets for each multiplication problem, and then end with another bracket. It's actually the same size as this one. I'm just kind of emphasizing that you have 2 here and that you have 2 here. After you do, oh no. So then you do that
But on
and
the
down.
decimal calculator, that's kind of hard to get it all because we're on time. And to punch each one of those in on a decimal calculator seems a little bit.
I think it's quicker doing it on the Desmos calculator than doing it a different way.
Okay.
So if you type in like that, the Desmos calculator will tell you the answer is 7.55. And then for the standard deviation, we would do the same kind of idea. Let's see, it's the STDEV. parenthesis, and if you remember that STDEV parenthesis, you can have the Desmos calculator just find the standard deviation for you. All you have to do is type everything in.
Yeah, I made it. I actually, this is reassuring because I did make it to this point when I was doing the like exam review a little bit ago, but then I got stuck a little bit before we logged in of what do I plug in there?
Now you can just type in again this 10
Like
times.
the full
Yeah.
thing.
Yeah, 10 times 6. Comma, but a comma between them.
Okay.
So 10 times 6, 9 times 13. I don't even think you need the parentheses. I think you can just write the numbers without the parentheses here.
Yeah, like just the multiplication sign and then
Yeah,
to divide them.
yeah.
Okay.
So 10 times 6, comma, 9 times 13. And dot, 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 dot. Just keep going with that.
Okay.
And then this one will chug out 1.5 for the standard deviation.
Professor, is there a way that you can show us what this is supposed to look like in the Desmos calculator?
Give me a moment. Let's see. Scientific. All right, you're going to see a messy screen for a moment. If I find my controls here. Nope, those are not my controls. Where are my controls? Oh, here they are. Share. Nope. You have to go to advanced and then portion of screen. All right, sorry. So you're seeing some of my desktop. Oh, some of you are writing stuff in chat. I'm sorry. I haven't been looking in chat. Let me skip that down. And on over. All right. So we're typing in STDEV parenthesis 10. Oh, and you have to do the time symbol on here. You can't do the X on your calculator or on your keyboard. So 10 times 6, 9 times 13. Now you see it's giving me an answer right here. But then when I type in my comma, now it's not giving me an answer because I need to type in the next thing. So 8 times 12. Do the comma on your keyboard there. Oh, I guess you could do the comma right there. I didn't even see that one. 8 times 12, 7 times 11. 6 times 15, comma, 5 times 5. With the bracket at the end. So there's my answer for that's not right. Need to put parentheses. What is going on there?
You have to still divide it by the total that was under it or no?
No, it should just be right there. It's still sticking with that 31. Okay, I guess I thought you could type it in like that. I guess not. I guess you have to do 10, comma, 10, comma, 10, comma. You get 6 of those. I swear I thought I did it without having to type in all of them, but I guess not. 1, 2, 3, 4, 5. 2, 3. Hopefully you won't get this one with so many things to have to type in on the calculator. 13 nines. Yeah, you won't get something like this, but make sure you count out very carefully. You just need to remember that STDEV, standard deviation. ST for standard, DEV for variation, standard deviation. It's very much perplexing to me because I swear I did this. Oops.
Good evening, Professor and class. I went ahead and put some problems that I need help with, or I'd love to watch you do them in the chat. And then just for all my classmates struggling with the Desmos, I went to YouTube and there's a lot of tutorials you can watch on how to do things. In case anyone wants to look, because I also had to teach myself how to use the calculator.
Okay, so let's figure out the rest of these questions here. What percent of the data lies within one standard deviation?
I'm sorry. Could we have you go back and finish the process for this? Because I want to make sure that I'm doing this correctly. I understand that there's YouTube videos, but I want to make sure that I follow this in my recording.
Oh, on this one, you just have to be sure to type in all of them. I'm not going to take the time to type in these 30 some numbers right now. I'm sorry.
I'm sorry, but how are we expected to do this on our own if I don't have a
Okay,
full
you want me to seriously count these out and take this
I
time?
do.
1, 2, 3, 4, 5, 6. I'm thinking we could spend our time a little bit better, but all right. And then 8. So I don't have what I have on the paper, so now I have to go back and type it all in and start all over again. But this is how you would type it in. I'm sorry, I'm not going to continue typing this all in again. The standard deviation is 1.5. If you want me to type it all in again, we'll do it at the very end. But let's go through the math for the other parts right now. But this is how you would do it. Just type them all in with the comma in between them. All right, so what percent of the data lies within one standard deviation of the mean? So this is our mean, and this is our standard deviation. So we are looking at the data values that are between one standard deviation above this and one standard deviation below this. So one standard deviation above this 1.5 plus 7.55. One point five plus, ooh, plus 7.55. I typed in the wrong thing. So 9.05. So that means 9.05. So I'm not going to include the tens on this one. And then 7.55 minus 1.5. And I get 6.05. Okay, so we are looking at the numbers between 6.05 and 9.05. We're not including the 6 because the 6 has a little bit, it's above the 6. It's not exactly 6. So we're going to include 6 plus 13 plus 12 plus 11. Are we including the 6? No, we are not including the 6. I'm sorry, I'm a little flustered right now. We're not including the 6. We're just including 13 plus 12 plus 11. And that would be 36 out of 60. It's asking for a percent. Like I said, I went through, and even in the normal distribution assignment, the 3.4, I went through and gave people partial credit for when they wrote their percent incorrectly. I'm not going to do that on the test though, but here you can leave it as a fraction, or you can write it out as a decimal, or you can write it as 60%. Maybe not this one. But when you're converting this to a percent, you're moving the decimal point 2 times because you're multiplying it by 100. So 0.6 becomes 60%. And if we go down here for 2 standard deviations, we'll do 1.5 plus 1.5 plus 1.5 plus 7.55 to get 10.55. And then we'll do 7.55 minus 1.5 minus 1.5. So 2 standard deviations, we subtract out 2, we add 2. And this one here, subtracting it is 4.55. So 4.55 would include the 5. And all the way up to the 10.55. So this would be 100% of the data. If this is 100% of the data, then 3 standard deviations is also 100% of the data. Otherwise, we would do 1.5 plus 1.5 plus 1.5 plus 7.55. So 3 standard deviations, we add it 3 times. 2 standard deviations, twice. 1 standard deviation, we do it 1 time. Does that help on that question? I hope.
Yes, it did for me, Professor. Thank you so much.
Uh-huh. All right, what question can we do next?
Can we do 24?
Oops. Yeah, I just kind of lost everything here. There we go. Number 24.
Please.
Oh, right down here. Sorry, looking for it and it's right there. All right, so this is preparing you for all these lovely story problems that come up afterwards, because you're going to be using this formula. And the formula is going to be written like this on the formula sheet. Okay. So this is Z equals X is our data item. This strange looking U is our mean. And then this one here is our standard deviation. Okay. And oh my goodness, I can't even still spell standard right now. Okay. So this is our data item. The X is our data item. It's telling us our mean is 20 and our standard deviation is 4.3. The formula is going to be written like this on the formula sheet. So this is something you need to remember, is that this mu is the mean.
Is the mean.
And the circle with the line in it is our standard deviation.
Okay.
Okay, so we're doing our data item minus the mean, data item minus the mean divided by standard deviation. So data item here is 40 minus the mean divided by the standard deviation. And if you do that in the calculator, I believe it comes up nice and neat.
I got 4.6, so 4.65.
Yeah, it does not come out nice and neat. So I always go out at least 2 decimal places and round.
Oh,
So this is what it is in the calculator. So this would 4.65. That 1 is not going to round it, so it would be 4.65. And then here we would just have 25 minus 20 divided by 4.3. And we get 1.16279. So we're going to go 2 places after the decimal. That 2 is not big enough to change it, so 1.16. Okay, is that making sense to you how to do those?
yes, it does.
Okay. Do you want me to do more, or are you good?
I'm good.
Okay. All right, what question should we do next?
I have several in the chat. If we could do, they're the big ones at the very back of the packet, the ones that require a lot of steps, starting at 37. I mean, you don't have to do all of them, but golly, if you could do a good amount, that'd be great.
Okay,
I don't
so
want to
let's
take all the
just-
time though.
No, you're not the only one who wants help on these, trust me. Okay, I'm gonna just grab the back. My Z table. Okay, in the Z table, The numbers on the outside are the z-scores. The
In the
numbers,
blue,
sorry?
the numbers on the blue are the Z scores, I'm sorry.
Yeah, the numbers along the outside are the z-scores. The numbers on the inside are decimals. No, I'm going to change that. They're percents written as decimals. So they're the decimal equivalents of the percents. So I believe like this first block of problems, I don't see a percent sign here and anywhere. So we're finding the percent on these.
What number are you doing? 37?
I'm just looking at it. I don't see any percents given. So I know I'm going to be looking for this number. I'm given this number, or I'm going to find this number. And we have to find the percent. And it is asking for what percent.
And
So
Professor,
remember,
oh, sorry.
go ahead.
Just to clarify, not to jump ahead too far, but if it were the reverse, if we were given the percent, like you're saying, we don't have a percent right now, but if we were given one, we would
If-
want to find the z-score.
Yes.
Okay.
If we're given a percent, then we're going to find that percent inside here,
Yes. Okay.
and we're going to find the z-score. Yes.
Okay. That makes sense. Thank you.
Okay. Yeah, that's just what I wanted to get across. So thank you for asking that.
Yeah, of course.
All right, so on 37, we know whenever we see a mean and a standard deviation in a problem, whenever we see a mean and a standard deviation, we're going to use the formula, the data item. I can't even spell tonight. Oof. Data item, I'm thinking ahead in my head. Data item minus the mean over standard deviation.
The standard deviation is the 2.2.
Yes. So given mean and standard deviation, we use this formula. Okay, but remember it's written z equals x minus mu. It's always going to be written this way on your formula sheet. Just remember the x is your data item. Mean, the standard deviation is always the smallest number, and that goes on the bottom, the smallest number. Well, I shouldn't say always, it's generally the smallest number. Okay. So here, oh, let me just write it out here. So our mean equals 9.6. Standard deviation equals 2.2. Oh, that's for this first part of it. Okay. And we're using data item minus the mean. We're looking for higher than 13. Oh, this is a little bit trickier. Higher than 13. So our data item is 13 minus our mean divided by our standard deviation. Okay. So you would just do this in your calculator. And doing this in your calculator, you will get 1.5454. Okay. See how this picture gives us, it's got the left side shaded? This paper is always giving us data's less than. So if we want the number of, for this white area, we need to take our less than and subtract that from 1. So this one's asking for higher than, greater than. So I can't just use it like this. I'm going to have to convert it, but I can't convert it yet. First, I need to look up that 1.54. So 1.54. 1.54. 0.9382. 9382. So this is my z-score. This is the percent. But this is the percent that are lower. If I want the percent that are higher, oh, you guys tell me, what do I do? Does anyone know what we do if we want the percent
You're
higher?
gonna minus it from 1, and then you'll get a
Exactly.
decimal and times it by 100 to get the percent. Am I close?
You're exactly correct.
Cool. I've studied all day, but still I feel like I need a lot of help.
But you explaining it right now means you know it and you're not going to forget it.
Ooh, good.
Okay, so ooh, I hit 1 point. So 1 minus 0.9382. And we get 0.0618. So I have found that if people type this in, it seems to count it correct. But just to be safe, I would always run or change it into the percent. So changing it to a percent, you just multiply it by 100, which is the same thing as moving the decimal point over 2 times. So this is 6.18.
So to get it higher, you have to subtract it from the percentage you already have.
Subtract it from 1.
I'll subtract it from 1. I'm sorry. Okay.
Right. Yeah, because it's saying this much of it is lower, 0.9382 is lower, and it wants
Mhm.
to know how much is higher.
Okay.
All right, so now for the between, I didn't even leave enough room here for this. Okay, so for the between, I have to do this formula for 8, and then I have to do it also for 11. So I'm going to do 8 minus 9.6 divided by 2.2. And I'm going to do oh, no, it's not 9.6 on this one. What is it on this one?
Is it the other one? Is it the
Yeah.
10.1 and the 1.4?
Yeah, this one's a nasty one where they give you 2
Yes.
sets of data.
Yes, it is. Yes, it is.
Yes, I agree. because this is the second part, they gave us new data for this one. So here our mean is 10.1 and our standard deviation is 1.4. So we're still doing 8 minus, but now minus 10.1 divided by 1.4. And then we're doing 11 minus 10.1 divided by 1.4. Are you guys good at typing these simple problems into the calculator? Into the Desmos calculator? We just do.
Yeah, I practice on the decimals. I
Yeah.
don't even use my graphing calculator just because
Good.
it's easy.
Good. So it's just 8 minus 10.1. You can hit equals, and then you can say divided by, oh no, you can't do that. I'm going to put parentheses around that. I always think you can hit the equal sign and it's just going to go with that, but it doesn't. 8 minus 10.1 divided by 1.4. And it's negative 1.5.
Mhm.
And then do the same thing for the 11. And the 11 is, well, here, let me write this one down. This one is negative 1.5. And this one is 0.6429. So we're going to take the larger one, 0.6429, and subtract out the smaller one. Oh, we're not subtracting yet though, are we? We have to convert these in the table. So 0.6429, 0.64 0.642, so I would just leave it at 0.64, and we get 0.7389 minus negative 1.5. So now I have to go to the other side, negative 1.5, and it's just negative 1.5, right? Nothing else? Yeah. So negative 1.5, 0.0559. Oh, no, no, no. I always forget that the 0 is over here on this side. So it's negative 1.50. I was doing negative 1.59, but it's negative 1.50. So 0.0668. 0.0668. And I'm subtracting in my calculator because it's going to go faster than if I do it in the Desmos one. But you would just subtract it the exact same way. And you get 0.6721. And if we change that to a percent, we just multiply it by 100. And we get 67.21%. So if it asks for a percent, you need to put a percent sign on it. Or you need to leave it as the 4-digit decimal. If you put it as 67.21 and you don't put the percent sign on it, it's going to mark it wrong. If you write it as a decimal and you write out the whole decimal, it'll count that correct. But whenever it asks for a percent, keep in mind, if you're rounding, if you're multiplying it by 100 to get it to a percent, you need to put a percent sign on your answer. Otherwise, it's wrong. Does that make sense, I hope? Sounds nasty, but it's the way it is. Do you guys want me to go through the rest of these problems, the 3.4 problems?
That would be great if you could, but again, I don't want to take the whole time up, but they're pretty tough. There's a lot of steps involved.
Yes. we
Anyone
do another-
else? Sorry, anyone else want to see these problems written out, worked out?
Yes, please.
Okay. All right, so the next one, the wear out mileage of Sparky's all-weather tire is normally distributed with a mean of 28,000 and a standard deviation of 2,400 miles. If the manufacturer guarantees the tire lasts at least 2,760 miles, what percentage? So what percentage means we're finding the number in here. This number in here is the percent. So we're finding the number inside. And we're given a data item here. Our data item is the at least number. Okay. So we're going to plug into the formula. Let's see, I'm just going to write it down here. Z equals data item minus our mean over the standard deviation. So 27760 minus 28,000 divided by our standard deviation. Okay, doing this in the calculator, you'll get negative 0.1. So just type in that 27760 minus 28,000 and divide that by 2,400 to get that negative 0.1. Okay. Negative 0.1. I look up around the outside. Negative 0.1. I'm going to remember to go to the end this time, because zero is up there. So 0, negative 0.1, 0.4602. So what percentage is that? We multiply this by 100, or move the decimal point over 2 times. We get 46.02. Okay, do you all understand why? Well, why I did what I did on this problem? Are there any questions on it? Am I done with it?
This one is more straightforward. Thank
Am I done with it? What's the trick in this one?
Is it that it's because I'm tripping up on the the part that's saying that the tires will live up to the guarantee. I feel like something about that is asking us something else, maybe not.
It's the trip up where it's saying it's at least. So if it's at least
least.
above it.
Yes, because of the at least. So we don't want the at least, we want the more than.
Oh, so we're gonna have to subtract from 1.
Exactly.
Okay, that
So
does make sense.
more than, we have to subtract our percent from 100. So 100% minus 46.02. 46.02%. And we get 53.98%.
Just for verification, you did 1 minus 0.4602. Is that correct?
Yeah, I didn't write down that, did I? Or I actually did 100% minus the 46.02, but you could do the 1 minus the, yeah, you could do 1 minus it. I just did it as the percent. So since I had the percent already
Oh, I
written,
got you. Okay, and you just did the percentage minus 100%. Okay, that makes
yeah,
sense. Understood.
either way it works. Yeah.
And it was 53.98%. Okay.
All right. Are you all good as to why we subtracted from 1 or
Yeah.
100%?
I think so, yes.
Okay. At least. That word at least. That's our key on this one. Okay. All right, let's look at number 39. This one, I tried taking off this last part of it because this last part of it was didn't seem to be calculating correctly. So I tried taking this off. If it's still on there, I'm not going to count this problem. Because it asks, I don't know if some of you did this one, falls within 2 standard deviations, but if we're saying that the numbers are normally distributed, it should be, normally distributed 2 standard deviations should be 95% of the data, but it wanted you to actually figure it out, and it's just,
I remember that one. I think it was like 95.44.
yeah, exactly, yeah.
Well, I appreciate you taking that off. That's helpful and also eases some anxiety for the word problem. So thank you.
Yeah, I'm not sure if it's actually taken off of everybody's test because, I mean, if you get this one, because somebody had already taken the test. So I don't know if it will get changed, but I will go through all of the tests and look for that one. Just as I went through all of the homework, all of the 3.4 assignments, and if someone was really close on a percentage, I gave credit for it because it depended on whether you used this or if you used the Z table, the applet that they give you. So I'll look for that too on the test. Do you know what I'm talking about? Like some of the answers are slightly different if you use the table versus the applet.
I noticed
So
a couple times, yeah.
yeah, so if that happens on the test, since I think all of these problems are with the Z table, so it shouldn't be a problem with these word problems. I think all the word problems are Z tables, yeah. Oh, yeah, so we shouldn't have that problem. It's the problems that were not Z tables that the answers were slightly different. All right, sorry, I'm digressing here. The extract of a plant native to Taiwan has been tested as possible treatment for leukemia. One of the chemical compounds produced from the plant was analyzed for partial collagen. The collagen amount was found to be normally distributed. Whenever you see normally distributed, you know you're using X minus the mean over standard deviation. Okay, so it's giving us our mean is 64. And our standard deviation is 5.8. All right, so we're plugging numbers into that formula. And standard deviation of 5.8. what is the probability that amount of collagen is greater than 60 grams? So our data item, our X equals 60. So we're doing 60 minus the mean divided by our standard deviation. And this in the calculator is going to come up negative because 60 minus 64 is going to give us a negative number.
A -4.
And it comes up to be a real long number. 60 minus 64 divided by 5.8. Wow, very long. Okay. So I'm going to go to 4 decimal places. So if you get a long number like this, go to 4 decimal places. So what is this? 0, negative 0.68965551. Okay, 689,655. So if we're going to 4 numbers after, that 5 is going to round that up. So negative 0.6897. Okay. So now what do I do with this 0.6897 number?
Subtract from 1, I think. Maybe, because it's greater than or no?
We're going to do that at the end. Before I subtract from 1, I need to use this table.
Oh,
See, that would have got me.
Okay. So the
Okay.
subtracting is at the end. Subtract from 1 at end.
Okay.
well, 0.68. Are we looking for?
So in the table, we're going to look for 0.69. Ooh, negative 0.69.
Okay, yeah.
Okay. 0.69. And I'm getting 0.2451 for that. I know you guys can't read that. I'm sorry. 0.2451. Okay, and this one did ask for greater. So once I found the decimal equivalent inside, now I can do 1 minus that number. Okay, when it asks for the probability, just leave it as a decimal. You could do 75.49%, but I would just leave it as a decimal. Okay, so the next one is asking for less than 83 grams. So our data item now is 83 minus 64 divided by 5.8. 83 minus 64 divided by 5.8 will give you 3.2759. All right, what do I do with that number?
Find it on the Z table.
And am I finding it on the outside or on the inside? Am I looking for, okay, I'm looking for the 3.252759 on the outside. So
Correct.
I can only go to 3.2759 2. Okay, so now I'm not going to use the 7 number. I'm going to round it up to 8. I'm going to look up 3.28. Are you guys okay with me rounding it up to 28?
Yes.
Because 5 rounds it up. So 3.28 all the way over 0.9995. Do I subtract this one from 100?
No,
Why not?
because it's less than, and that's what the table gives us.
Exactly.
Yeah.
Are you guys getting good with that? I hope so.
Better.
Yeah.
Okay. All right. The physical fitness of and I'm sorry, any questions on either parts of those? Okay.
Professor, I have a general question. I've been following along and doing some of these in Affinity, but where could I find this version of problems that you're working off of?
Oh, it's in the announcement about this exam review. In Canvas, if you go to the announcement that has the information about this exam review, there's a copy of this.
Perfect. Thank you.
Okay. All right, so number 40, the physical fitness of an athlete is often measured by how much oxygen the athlete takes in, which is recorded in milliliters per kilogram. The mean maximum oxygen uptake for elite athletes. So the mean is found to be 60. And our standard deviation is 8.2. Assume that the distribution is approximately normal, meaning we can use the z-table. What's the probability that an elite athlete has a maximum oxygen uptake of at least 60? So that means our x equals 60. So we're using that z equals our data item minus the mean over standard deviation. So 60 minus 60 divided by 8.2. Well, this one's interesting. So 60 minus 60 is 0. 0 divided by anything is 0. Why did I write? Oh, no, it is 60 divided by 60. 60 by 60. Yeah, 0. Okay. It just seems weird to me. If we look this up in the table, the 0.00 on either side, 0.00 or even the negative 0.00 is 0.500. Probability, you can just leave it like this. If you're so inclined, you can change it to the percent, but you can just leave it like that. All right, probability that an elite athlete has an uptake of 55 or lower. Okay, so our x is now 55. So we have 55 minus 60 divided by 8.2. 55 minus 60 divided by 8.2. Okay, so this gives us a negative answer, negative 0.60975. Always go, if you have a decimal that's really long like this, go out 5 places and check if you can round. And if you can round for 4 decimal places, like in this case, I can round up, so negative 0.6098. Although that doesn't really matter right now. It'll matter more when we get to the other problems. So here, though, I can only look up 2 numbers after the decimal point in here because I'm still looking along the outside since we are given the percent. So I'm going to
Excuse
look
me,
up.
Professor.
Yeah.
So I'm not going to use that 9 and round it to negative 0.61.
Yeah.
Yes. Okay. Sorry. I didn't see you writing that. Okay. So
Yeah.
I think that's what's confusing me is when I round, when I don't, how many decimals do I have to use? So I'm watching and also taking notes simultaneously.
Mhm,
Thank you.
mhm. Yeah. Okay, so then we look up negative 0.61, negative 0.61, and that's 0.2709. Six one 0.2709. And that would be 27. Oh, no, we can just leave it. We can just leave it like this since it's asking the probability. Okay, so consider someone with a maximum oxygen uptake of 36. Is it likely that this person is an elite athlete? If their oxygen is higher, I would say no, they're not an elite. Did I look this one up right? Negative 6.1. I'm really not good at looking things up in this table. My eyes are too old for this. 0.2709. Yep, that is right. Yeah. Your eyes just kind of go when you get older. Sorry. I'm sorry, any questions on that? Do you understand why I said no on that one? Does anyone not understand why I said no on that?
I don't.
I mean, I think you said no because the oxygen uptake was a smaller number compared to the other 2 questions, because the other 2 questions referred to the athlete as a elite athlete and they had a higher oxygen uptake. Is that why?
Yeah, well, yeah. So we could do this. 36 minus 60 divided by 8.2. But yeah, let's just do that. 36 divided by 60. Or 36 minus 60 divided by 8.2 equals, so this is negative 2.93. Negative 2.93 is 0.007. No, 0.0. 2.9. Telling you my eyes are too old to be looking at this thing. Yeah, so this is just maximum intake. So sorry, then we'd have to subtract this from 1. And that's going to be quite a bit higher than that. And we're looking for lower. So that would be a no. Number 41. Okay, combined math and verbal scores for females taking the SAT test are normally distributed with a mean. Isn't it funny how everything is normally distributed? We have a mean 998.
Would you mind pulling down your paper?
Yeah, I
Thank you.
just
Thank you
noticed
so
that.
much.
Yeah. Thank you for saying something. Okay, mean 998, standard deviation of 202. Based on the data from the College Board, if a college includes a minimum score, so minimum is important, of 875, what percentage of females do not satisfy that requirement? All right, is this problem like the ones that we were just working on?
Yeah.
Okay, so we were given 2 numbers. So normally distributed, we're given a mean, a standard deviation, and we're given the data item still. Okay, so we're still finding our percent. So we're still doing we have the data item minus our mean divided by our standard deviation. So 875 minus 998 divided by 202. Okay, so this is 25 minus 998 divided by 202 equals negative 0.60891. Okay, so what am I looking up in the table on this one?
-0.60.
Negative 0.61.
1.
Negative 0.61.
Yeah.
All right, we're all good with that? That was nice how you guys talked it out and you figured it all out together there. Negative 6 or 0.61 and 2709. Okay, what do we do with that?
We need to convert that to a percentage, I think. Or am I a step ahead already?
So if we convert this to a percentage,
You could either, yeah. Mm-hmm.
Right? Because that's all it's asking, right?
yep.
Yes.
It's funny when they're long and the sentences go on, my brain's like, okay, it's gonna be at least 14 steps. Like so when I look at it, I'm in disbelief sometimes when it's just a few like that.
Yep,
Yep.
that's all I can say about that. Yep.
Yep, that's math for you.
Uh-huh.
Okay.
All right. How is this next problem different?
I think these are different because we're given the percentages, right?
We're given the 95th percentile, so we're given percent. Oh, where's the paper that I wrote that on? Okay, so we're given the percent. Now we're finding the z-scores. So we're given the 95th percentile. So we'll start by looking up the 95 percentile inside here. Okay, so let's so let me write down what we're given here. We are given a mean of 0. Our standard deviation is 1, equals 1. And we're given 95th percentile, which would be 0.95. So given percent, okay, sorry, am I looking up the 0.95 in the inside or along the outside?
The inside?
Okay. We're looking for the percent inside the table. Do you know what I mean by inside table? Inside, we're looking for it over here, as opposed to looking for a z-score on the outside. Okay, so we're going to look for 0.95. I'm on the negative side, I'm not seeing it, so I'm going to flip over. And it's very rare that you're going to find one that actually gives you the exact 0.95. .95. Let's see. So I've got 0.9495 and I've got 0.9505. Either one of those would work.
Would you choose the 9495 because it's below the 9.5?
I would choose this one because of that, yes. But they're both 5 away, so the answer should take either one of them. So this is one, so I'm looking over here, 1.64. So the 1.64.
Just so that I'm clear, you're using the 9495, correct? I can't read
Yeah.
your numbers on the screen, so I don't know which column you're looking at.
I can't read the numbers and they're right in front of me here, so
It's definitely hard to see over the Zoom.
yeah. 0.94, I'm looking in here, 0.9495.
Okay, so you chose that one. Thank you.
So 1.64. So what is 1.64? How do I use this?
That's the z-score.
This is our z-score. So in z equals the data item, just run those words together, minus the mean over standard deviation. This is this number now. So now we have 1.64, and we're looking for our data item.
Are you solving for X? Is this going to start becoming algebra?
We are solving for X. We were doing algebra before though, too. I mean, because this is like X equals or Z equals.
Yeah, that's true. That's true.
Sorry, everything can be algebra.
It truly can. Thank you.
Okay. So 1.64, we don't know our data item. We know our mean is 0 and our standard deviation is 1. All right, so I'm just going to go through all the steps of working this out, although this one kind of works out nice. Going to multiply both sides by 1 to get rid of this 1 down here. So 1 times 1.64 is just 1.64. 1 times that 1 is nothing, equals X minus 0. So 1.64 equals X. And that's our answer. Okay.
And Professor, is it applicable to say that if we bump into a question like this on the test that asks about the percentile, that like we will be solving it this way no matter what?
Yeah.
Okay.
Mhm.
Okay, that's good to know. Thank you.
Yes, so anytime we're given the percent, we'll be solving for the data item. The percent is always that Z part. Okay, or sorry, given the percent. Let's just do number 43 before I blah, blah, blah. Okay, given our percent, we're given 10% on this one. Oh, let's see here. We have a mean. I'm so bad at these problems. I just look at, okay, mean of 0, standard deviation of 1, and I just look for the data in it. I don't even read the problems half the time. Sorry, I'm so bad about that. So if 10% of the thermometers are rejected because they have readings that are too low, but all other thermometers are acceptable, find the reading that separates the rejected thermometers from the others. All right, so 10% are rejected. What am I looking up in the table?
So these ones kind of confuse me because some of the problems we did, we had to take 100% minus the percent in the problem. Is this one of those problems or no?
It's not asking us to find more than 10%. It's just saying that 10% are too low. Find the reading that separates them. So we're going to use it as 10%.
So you're gonna make that 0.10 and look up on the Z table where 0.10 is located.
Am I looking for 0.10 in here or out here?
You're looking for 0.10 on the outside.
Okay. Anytime we're given the percent,
Look inside.
Inside. Okay.
looking for the percent or wait, given percent. I don't know why I said looking for percent here. Given percent inside table. Given percent. Look inside table. So we're going to look up 0, or 10%. So we're going to look up 0.1 inside the table. Are you guys looking it up, or do you not have a table in front of you? Sorry.
I don't have a table in front of me.
Well,
I'm
why
trying to
not,
look at yours.
people? You
I
don't just
was-
keep a table handy with you?
I do have it open. I think I just saw it, and then right as I turned my mic on, now I'm trying to find it again. I think it's between negative 1.29 and the one right next to it. Negative 1.28, if I'm not mistaken.
Negative 1.28 or negative 1.29. Negative 1.28 is 0.1003. And we're looking for 0.1 and 0.129. So this is 15 below, or 0.0015 below, 0.0015 below, and this one is 0.003 above, 0.0003 above. So this one is closer than negative 1.28. All right, so what am I doing with the negative 1.28 now?
Are you going to put it in the z-score and solve for x?
Okay. So that's in for the z-score. So using the same formula, but our z is negative 1.28 equals, we're finding the reading, we're finding the data item. So that's x minus our mean of 0 divided by our standard deviation of 1. So we're going to do negative 1.28 times 1 to get rid of that 1, which is just going to give us negative 1.28 equals x minus 0, or just x equals negative 1.28. All right, we'll get to some that aren't so weird like these two, where they're so easy, because it might not be that easy on the test with the over the 1 thing. Okay. So women's weights are normally distributed with a mean given by 143 pounds and the standard deviation of 29. Find the 6th decile. So 6th decile, D6. Oh, here it tells us. I was going to say what it was, but I don't need to, which separates the bottom 60% from the top 40%. Which separates the bottom 60% from the top 40%. So are we going to use the 60 or the 40?
I'm guessing 60.
We are going to use the 60. From the bottom
I
60.
guess 60, but can you explain why, please?
Hmm. My mind is going blank right now. We could do it from the top 40 and then subtract from 100%. But since it's telling us which separates the bottom 60%, let's just use the bottom 60%. If we did the 40%, that's going to give us the top, and we'd have to subtract it from 1 anyways. So if we use the top 40%, we'd have to subtract from 1 and give us an extra step. Whereas this one, we can just use the 60%, and we're not going to have to subtract at the end. Or subtract change our percent or anything else. Okay, so we're going bottom 60%. So where am I looking for the 60%?
Inside the Z table?
Okay. Are you guys getting comfortable with the percents? You're looking them up on the inside. Percents. Remember that when you're given the percent, look inside the table. Maybe get a tattoo of that. Well, no, you can't get a tattoo of that. You wouldn't want that. So top or the bottom 60%. So bottom 60. Bottom 60. All right. So I'm seeing it's between 0.5987 and 0.6026. So it's between 0.5987 or 0.6206. Okay, so how do we determine which one we're going to use?
We have to find the one that's closer to 60%.
Okay, so what we can just do is we can do 0.6. If you're not sure, do 0.6 minus 0.5987 and do 0.6 minus 0.62, oops, 6206. And we get 0.206. So which one is closer? You can't see my calculator. There you go. So which one is closer? The one that's 0.0013 or the one that's 0.0206?
The former. The 0.0013, I think.
Right. So we're going to use the 0.5987. So the 0.5987 is 0.25. Are you guys okay with how we did that? Any questions?
I looked down for a moment because I was writing it down. Can you just back up just one step and say what you did that last little piece?
Okay, so it was between two numbers, 0.5987 and 0.6026. So I did 0.6 minus each of the numbers. And the 0.0013 is smaller. So we're going to use that 0.5987. Oh, which is, sorry, 0.5987, which is 0.25. 0.25. So bottom 60% equals the 0.25. So 0.25 equals our data item, which we're trying to find, minus 143 divided by 29. So 29 times 0.25. Should I write that out, or do you guys need to see those steps? Sorry, 25 times 29 equals x minus 143. 29 times 0.25 is 7.25 equals x minus 143. So x equals, I'm going to move the 143 to the other side. So we're going to add it to the other side. So x equals 7.25 plus 143, which is 150.25. How we doing, gang? Anyone still here, or is it just me?
Yes, hanging in, trying to write it
Hey.
down.
No, we're here. Our
Okay.
brains are smoking, but we're here.
Right.
We're keeping up, trying to.
Sorry,
Here's one thing that I'm honestly struggling with.
Mhm.
There's so much words in all these and numbers that we don't use for the answers that when I do it, I feel like I'm not doing it right because there's so much more data that I haven't pulled out. Does that make sense? Like it doesn't matter if it's in the sixth decile, like that, what is that? That's not even, we're not even using that, but I see that and it makes me nervous. Like I should be doing like a 6% or something.
Okay, so 6th decile, D6 is all the same thing as 60%.
Yeah.
They're just throwing in these fancy things to mess with your brain.
They really do. And I think that's what
Yeah.
it does, is I feel like I solve it and then I think, oh, I guess I'm not doing it right because
You didn't use D6.
correct.
Yeah.
Correct.
Mhm.
can I just clarify why you ended up multiplying instead of doing 0.25 minus 143? I got a little confused on that step, I guess.
Okay, so algebraically, to solve for x, the first thing we have to do is get rid of this divided by 29. So to get rid of divide by 29, you have to multiply both sides by 29. So it's one of those rules of algebra. We have to get rid of the divided by 29 first.
Okay, got it.
I
Thank you.
heard in one of the review videos it said, I don't know why it didn't click for me before, but when they said that since those essentially they just become one and then anything divided by it, wait, now I'm confusing myself. Because you divide that by one and it's just going to be 143, right? Or no? You know what? I'm gonna backtrack that statement because now I'm confused.
Yeah.
It's okay. I trust my calculator enough for that part. It's all right.
The calculator will do it for you.
Yeah.
All right, we ready to move on to the next one?
Yes.
Yeah, you guys are so ready for this. All right, 2 more problems with a lot of parts to them. Okay. So IQ scores are normally distributed with the mean of 100 and a standard deviation of 15. So mean of 100, standard deviation of 15. Sorry about that. We're in view now. Okay, IQ scores are normally distributed. Blah, blah. Mensa is an international society that has one and only one qualification for membership, a score in the top 2% of the populations on an IQ test. Okay, what IQ score should one have in order to be eligible for Mensa?
Is this where we do 100% minus 2% so we can get the lower number and use the Z scale, that table?
What do you guys think?
Yes.
I'm
Is it just-
hesitant. I don't know.
It is a yes. You are correct because it's the top 2%. And the table is going to give us the bottom. So we need to do the 100% minus the 2%. And we'll use it as 98%. Okay. What do I do from here?
Okay, I think you're gonna take the 98 and you're gonna make it a decimal and then look for it on our table.
Okay, am I looking inside the table or am I looking for 0.98 on the outside?
You're gonna be inside in the white.
Okay, because anytime we are finding data item, we look up the percent in table inside the table. All right, you guys good with that?
Yes.
Yes.
Okay. So we're finding 0.98, and there are so many 0.9s on this thing. 0.98.
Is it 2.05?
Or is it 2.06?
Can you tell us the numbers of 2.5 and 2.6 so we know what
Come on, you can't read that?
I certainly can't.
Okay, so one is 0.9798 and the other one is 0.9803. Which one do we use?
Is this when we subtract the 0.98 from both of them and get the lowest, or should we just know by looking at it?
How far away is each of them from 0.98? Because I want 0.98. How far away is each from 0.98? What do I have to add to this one to get to 0.98?
0.02?
Okay. What do I have to subtract from this one? Because this one's above. What do I have to subtract from this one to get?
0.03? Oh, I see the extra zero. Okay.
No, I didn't put the extra zero here either, though. So here
Those get me every time.
I'd have to add 0.0002. Here, I'd have to subtract actually 0.0003.
Oh, okay.
Okay,
That makes sense.
because if I want to get rid of that, or if I need to add to that. So which one is closer? 0.0002 away or 0.003 away?
The 2 away.
Yeah. So you were right with the 0.9798. I was just trying to make us see why. So 0.9798. Oh my goodness. And what one is that? 0.9798.
2.05.
Oh, thank you. Okay, so 2.05. So now what do I do with 2.05?
You put it in the z-score formula,
Okay,
solve
so
for x.
2.05. Is that on the top of the fraction or is that what it's going to equal?
What it equals.
Okay. So do I know my data item?
No.
No.
That's what we're finding. So it's x minus, what are we subtracting?
100.
Okay, we're subtracting our mean. And we're dividing by
The standard deviation.
the standard deviation of 15. Okay, so how do I solve this?
So you're going to multiply the 15 on both sides?
Yes, don't say it like a question. You know it.
Okay. I'm skeptical every time.
So we multiply both sides by 15 to get rid of that 15. And 15 times 2.05 is 30.75 equals x minus 100. So now I want to get the x alone, so I'm going to add 100 to each side. So x equals 130.75. Can you read that small thing right there? 130.75. I hope you guys are okay with me asking you guys questions and not just saying it all.
It's actually helpful because it mimics how I have to talk to myself during the test to make sure I'm understanding the question. So I appreciate it.
Good, good.
Oh my gosh, I do the same thing. I talk while I'm solving these problems out loud. I have to say it out loud. It makes sense. I have to
We're
externalize
not
it.
alone. Yeah.
There are many like that. Many, many. All right, so now we've got part B. In a typical region of 55,000 people, how many are eligible for Mensa? So what am I going to do with that 55,000? And the hush falls over the crowd.
Is
Is
that
that the score?
next?
I'm sorry, I heard two of you talked at the same time and I didn't hear. So this one is kind of tricky.
Is this one the z-score?
We're going to take this times the percent. Like if there were 100 people at a store, 100% of people at a store, what is 5% of that? So we're doing, we're we're doing the top 2% of the 55,000. So of always means multiplication. So 2% times that population of 55,000. But we're just going to leave it as like 0.2. Oh, no, 2%. 2%. So 55,000 times 2% or 0.02 equals 1,100. Only 2% of these people will be eligible, or 1,100.
It's very small odds.
Mm-hmm.
Wait,
So
that's
there-
it? Wait, where's the next steps? Just kidding.
I know, right? There's got to be more to it, but there's not.
Yeah, I'm grateful for those simple ones. I'll take them.
Mm-hmm. All
I
right.
hope
let's
we have a
see.
few of those sprinkled into the exam. Fingers crossed.
Yeah. All right. Let's look at the last one of these. Healthy people have a body temperature that are normally distributed with a mean of 98.2. And a standard deviation of 0.62 degrees Fahrenheit. If a healthy person is randomly selected, what is the probability that he or she has a temperature above 99.8 degrees? What are we finding here? Are we finding, so if we do this formula, Z equals our data item minus the mean divided by standard deviation. Let me go this way. What do we have for this problem? So I know that we have the mean and the standard deviation. What's the other number? Is the other number an X or is it a Z?
I'm pretty sure it's an X.
And what's the key thing we know that it's an X and not a Z?
I want to say because it's not a percent.
That's exactly it, because it's not a percent.
Okay.
Perfect.
Okay, so this is our data item. So we're doing 99.8 minus 98.2 divided by 0.62. And that's Z equals. So 99.8 minus 98.2 divided by 0.62. So I have 2.58064. Is this my answer?
No.
Okay, so anytime we're given data item, or sorry, anytime we are given a mean and a standard deviation, you know you have to use the table. Anytime you have those two things, you're going to have to use the table. Okay, so 2.58. Am I looking for that inside the table or outside of the table? Inside of the table is the percent, outside of the table is the z-score.
So it should be outside.
Okay, because this is not a percent.
Right.
So we're going to look up 2.58, and we're not going to round that up. So 2.58. Where my eyes go wonky. I've got 0.9951. Okay,
That's making sense. I get that.
okay. Are we done?
It's going to sound like
No,
a question, but I think so.
no, you should make that a percentage, correct? The probability?
We can leave it like this.
Yeah, I didn't ask for the percentage, so what's the probability? Shouldn't we just leave it as a decimal?
Yeah, we can do that.
Would the alternative be to move the decimal place so that you're putting it in like that it would read like a temperature? Or is that just like an unnecessary step my brain's trying to do?
No,
Like we don't need to put it in like that?
no.
Okay.
Okay, so when do we subtract from 1? When do we not subtract from 1?
You
I've got a
subtract
little.
1 when there's a percentage, correct? Or you
Uh,
subtract 1 when you're going to the right of the.
it it
Okay, so
temperature.
let's read the question. If a healthy person is randomly selected, what's the probability that he or she has a temperature above 99.8?
Greater than, because it's asking greater than, we subtract 1.
We
Mhm.
subtract from 1.
Sorry, I couldn't see the
That's
question.
okay. Okay, do you understand why we're subtracting it from 1?
It's
Yes,
just because of the word above.
greater.
Mhm.
Okay.
Mhm.
So 1 minus 0.9951. 0.0049. And with this problem, it kind of makes sense that if a healthy person is selected, what's the probability that they're going to be above the normal 99.8? So it's got to be pretty low if the person is healthy. Sometimes you can reason it out that way. Not always. Sometimes you got to use the context clues, the above. Okay, part B. A hospital wants to select a minimum temperature for requiring further medical tests. What should that temperature be if we only want 2% of the healthy people to exceed it? So we have our mean of 98.2 still. Still have our standard deviation of 0.62. But now we have 2% that we want to exceed. Okay, you guys tell me, what are we doing here?
Are we minusing 100% again or no? I feel like that's my go-to with these ones that say want to exceed.
And that's a good go-to when it says want to exceed. So we're going to use the 100% minus 2% is 98% because we want to exceed. We're going to use the 98%. Okay, so now what do I do with that?
You make it a decimal and then we look for it in the table in the white area.
Okay. So 0.98. .98. Okay, so I've got 0.9798 and 0.9803. What do you guys think? Which one?
Didn't we just have this and we chose the 0.9798 because it was 0.0002?
Mm-hmm.
Okay,
So this one's further away. So we're using the 0.9978. Oh, 0.9978. Sorry, I forgot to look it up. 0.997. 2.05. So 0.98 equals the 2.05. All right, it's our last problem. Tell me what to do. What's my equation?
we put it in the z-score formula as it equals 2.05 and we solve for x.
Mm-hmm. Yes, ma'am. So it's our data item minus our mean. Over our standard deviation. So our z-score is 2.05 equals our data item minus our mean divided by our standard deviation. We have to multiply both sides by that 0.62. Like 60 times 2.05 equals, I got 1.271 equals to x minus 98.2. So to get rid of this, I need to add 98.2 to each side. So plus 98.2 and x equals 99.471. All right, how are you guys feeling about these problems now? Hopefully a little better.
A little better, for sure, a little better.
Yeah, me too.
Will you have this recorded and put in the announcement? So we can do a playback if we need to?
Yeah, I won't have it done until tomorrow morning. Probably late morning because it takes me a while to get it and download it and then get it into a format that I can share with y'all.
No problem. Thank you very much, Professor.
Yeah. All right. So we did all those problems. Are there other problems you wanted to see worked out from this? I know we did all the 3.4 problems. Is there anything else in here?
I do. I'm sorry. I know we kind of went over this earlier, but could we please, Professor, just go over, for example, number 31 and 32, please?
No, because you said please, no. If I can find them, oh my, what happened to them? 31. I really don't know what happened to them. 36, 39, 34, 41, 45.
It's not meant to be.
Oh my word.
It's those brackets.
Well, I have my answer key thing, so I got them in the answer key, I'm thinking. Hopefully I
Yeah,
didn't
that's
there.
yeah, that's fine. I just want to make sure. Yeah.
Oh, it seems like I'm missing it there too. Oh, the numbers are weird. How is it? 59, 30, 31? Oh, my. These problems?
Yes.
Okay. Look, 59, 30, 32. Oh, there is a 31 in there. Okay. All right. So to find the area between, you look up each z-score. So you look up the negative 2.4 and you look up the 0 and you subtract the two from each other. Or the smaller one from the larger one. Always subtract the smaller one from the larger one to get the distance between. And if you get the applet for that, if you're finding the in-between, you're never going to be finding this one right here. We don't have any questions like that. But if you're finding the in-between, you're using the brackets that close in on each side. And you'll type in the negative 1.52 on the left side of the bracket, and then the 2.55 on the right side. And it'll just give you the answer.
Okay, perfect.
Okay.
Professor, could you leave your screen on those on that paper so I can copy the answer?
Mm-hmm.
Gosh, I didn't realize that we were only a small few left. Most people left the Zoom.
Mm-hmm.
Well, I appreciate it. Thank you so much. I'm gonna go ahead and jump off. I need to
Okay.
get some more work done and put my kids to bed, even though I know it's spring break. So thank you so much, Professor, and good luck to all of you. Do well tomorrow.
You too, Nikki.
Thank you.
Good luck to you. Thank you.
All right. The rest of you, what kind of questions do you want to go over? Do you have other questions? Okay, so starting from the beginning. So frequency, well, I'm sorry, relative frequency is different than frequency. Frequency is just the number. Relative frequency is the fraction or the decimal equivalent of the fraction. Stem and leaf, the thing on the stem and leaves is that your leaves need to be in order from least to greatest. So 40, 45, 45, 45. So I'm going to have fives. And then 46. No commas between them and in order from least to greatest. And this one here, you've got two numbers. So the first two numbers are your stems and the leaves are the ones digit. Okay, so we talked about this earlier. The left side includes the number given because it's got that less than sign. The right side does not include it because there's no equal to symbol there. Okay, you all know how to find the mean. Median is always the middle number when the numbers are in order from greatest to least. So ordered numbers are least to greatest or greatest to least, either way. Okay, for mode, the way this system is set up, if there's more than two, there is no mode. So here we've got 17, 17, oh, but here we've got 11, 11, 11. So it looks like 11 would be the mode here, the one that occurs the most. I'm just kind of going through this. If you guys have questions for me, just shout them out.
I have a question. So you were saying if the mode, if it's more than two, are you saying
If there are more, I'm sorry, the way I said that, if there are more than two, if there are.
so like
There.
more than two pairs or two occurrences of the number?
If there are more than, if like, so 11 occurs 3 times. If 17 occurred 3 times, then there would be 2 modes, the 11 and the 17. But if the 14 also had 3 occurrences, so 11 has 3 occurrences, 14 has 3 occurrences, and the 17 has 3 occurrences, then there would be no mode. Because there are more than 2.
I got you. Okay.
Okay.
Thank you.
Mm-hmm.
If there are, if I could just ask a question to clarify, if there are 2 modes, we would list the 2 of them, but if there are more than 2, then we would put none.
Yeah, whatever it tells you to type in. I think it is none, isn't it?
I think so. Thank you.
Yeah. Okay, so here.
I didn't remember that. Thank you for pointing that out. Thank you.
Oh, you're welcome. Hopefully you won't get one like, well, the mean isn't too hard to do on the, actually, this isn't too bad for mean, median, mode. Mode is obvious on this one. It would be the 9 and the 6. The mean, you'd have to multiply all of these and then divide by the total. Do you guys know how to do the median on data like this?
Yes.
Without listing them all out. So find add these all together and divide by 2. 4 plus 11 plus 10 plus 9 plus 11 plus 3. So there are 48 numbers, so that means we want to find where that 24th one is, and you just kind of keep adding. And I've got 25, so I've included the 24th number already. So that would be our median. I'm going too fast, and this is probably not helping because I'm going too fast. Are you guys good with problems like 11 and 12?
I'm good.
Okay. You guys good with the box and whisker plots? So the smallest number is always the minimum. The largest number is always the maximum. The median is always that line. The median of the lower half of the data is one side of the box. And then the median of the upper half of the data is the other side of the box. And that's why they have you calculate the mean, median, mode. Or I'm sorry, the minimum, quartile 1, median, quartile 3, and maximum. Okay, so standard deviation, standard, is it STDEV? I think it is standard deviation, and then type in your numbers with a comma between them. On the Desmos calculator to get your standard deviation. You guys don't know it, but you're very lucky that you get to do that on the Desmos calculator, because it used to be that they'd have to do it the longhand way.
I'll try that for the exam, but when I was working with a tutor, they showed me doing each number manually. And so I'll try it on the Desmos calculator this time.
Yeah, I'd really try it because it's much easier.
Professor, could I ask real quick, could you jump back to maybe like could we do just number 14? I just kind of want to see how those are set up. It's still about like it's like the mean salaries and it's asking about median, but then there's a second part to the questions, and I just want to make sure I'm setting those up right.
So the mean number of hours that Raphael worked over the past 4 weeks is 34.75. So 4 weeks is 34.75. If he works 40 hours this week, what will be his mean? So what are you thinking about on this one? Any thoughts? Okay, so we know for 4 weeks, let me go backwards. To find average, we
So
take
four.
all of our numbers and we add them up and divide by how many there are. We know that a group of them are 34.75. We know that 4 of them specifically average out to 34.75. So we're going to take those 4 weeks. So 4 weeks times 34.75 plus the 40 hours in this new week, or new day, sorry, new day, and divide it by 5-week period. So since this is for a 5-week period, we would divide this by 5. So 4 times 37.5, because 4 weeks it averaged that much, plus the 40 more for that additional week, and divide by that. Divided by 5. We get 35.8 hours is the mean for the 5 weeks.
Okay, fantastic. Thank you so much.
Mhm.
Would you mind going back and working either problems 11 or 12? Please.
Yeah. Is it okay if I pick number 12 just because it's smaller?
No, that's cool.
Okay. All right. So the mean, it's got less problems on it, sorry. The mean salary for 13 men is 53,000. Isn't this the way it is? The mean salary for 9 women is 45,000. Women are always less. Okay. So we've got 13 men at 53,000, 9 women at 45,000, for a total of 22 people. So I'm going to take those 13 men and multiply them by the 53,000. I'm going to add that to the total of 9 women times 4,500 each, 45,000 each, sorry. And divide that by 22. Does that make sense how I set it up?
Yes. Mm-hmm.
Okay. So then 13 times 53,000 plus 9 times 45,000. This is so much easier to do in the Desmos calculator than my own. It's just, I've got it in front of me. So 49,727, and then it's 0.2727. And we always round money to the nearest cent unless otherwise specified, so 0.27.
Thank
Mm-hmm. Do you want the answers for number 11?
Yes, please. Why not?
Okay.
Yeah.
So if you work it out yourself, this one's 88%, 92%, and 142%. So that's not possible. Talk about hops and whiskers. Standard deviation. This whole page is about standard deviation. And then we got into the 3.4 stuff that we pretty much went through all of those.
Quick question, Professor. For question 21 that is about standard deviation, it's the one with the months and then the inches of rainfall. Is that one where we would just plug in those numbers with the standard deviation in the Desmos, like in parentheses? Okay, perfect. Those are, I was struggling with those in the homework, but I think it was just because I would like miss a number here and there just because it, is so long to type out.
It
But-
is, yes.
Yeah. I'm grateful to not have to do it by hand though, so I'll take it.
Yes.
Thank you.
Mm-hmm. Yeah. Last semester they had to do it by hand, and you guys don't have to. So that's nice.
Absolutely.
All right, how are we feeling, gang?
Way better than when we started, so thank you.
Mm-hmm.
Way
Okay,
better than when we started. Brain is a little mush, but
Yeah.
yeah, a
You've
little
been here
Yes.
for 2 hours and 50 minutes. Your brain should be at mush.
I know, I looked at my clock. I'm like, oh, it's almost midnight. Okay, right on time.
Yeah. Yeah.
Crazy.
It is 1 a.m. here.
Oh my
Oh
gosh. I
my.
feel you.
I'm sorry.
It's okay. It's worth it because I thought, well, you can sleep on it, let, our brains absorb the information, and then hopefully tomorrow it'll feel, all systems go.
Yes.
Sorry, Professor, can I please just have the answer to number 59? I'm nervous about the brackets. I know I did it in the homework, but I don't know.
In for 59?
Yeah, it's after 29.
Oh,
It's those bracket
well, that
questions.
makes sense, doesn't it? Um, it's after what number again? Oh,
29?
29. Oh,
Yeah.
59. Okay.
I just want the answer. Okay, so it's to the right. Okay.
Okay.
70, 19.
Okay. Anyone gonna get any sleep tonight?
We'll see.
We'll,
I
I
hope
hope you
so.
do. I
we'll
hope so.
definitely see. Yeah.
And you'll be dreaming of standard deviation and z-scores and
Oh my gosh,
I
I'm counting. I have 3 weeks left of school or math.
we're so close. We're at the
We're
halfway
so
point.
close. So close. You can do it.
Well, thank you so much, Professor. This is incredibly helpful, and I really appreciate you taking the time to do this for all of us.
Oh,
Yeah.
you're welcome.
Thank you very much.
All
Really.
right. Well, good luck tomorrow or bad luck tomorrow, whatever I'm supposed to say to not jinx you or anything. I wish you all the best.
Thank you so much.
All right.
Thank
Good luck,
you.
Good night,
everybody.
everyone.
Thank you.
Get some sleep.
Thank you.